Certifying multicore processors to DO-178 guidance, including meeting CAST 32A objectives, is a complex undertaking. Rapid's CAST 32A compliance solution reduces the cost of the certification process. A key part of the solution is software tools that automate and support different parts of the overall multicore certification workflow, specifically the platform characterization and software characterization phases. The tools used are as follows: Rapitest for writing, managing and executing multicore timing tests, Rapidtime for instrumenting and analysing timing and performance metrics, Rapitask for visualising multicore scheduling, and Rapidemons to exercise interference channels. In this video, we'll show you how these products support multicore timing analysis on a demo platform, a multicore matrix multiplication application running on the Xilinx UltraScale Plus ZCU development board. One of the timing requirements for the application is that the worst case execution time of the worker 1 task should not exceed 1300 milliseconds, even when there is interference on the L2 cache. The tool automation workflow includes 4 stages: creating a test harness, running tests and collecting test results, analysing results, and finally exporting results. The first stage is to create a test harness that can run tests to investigate interference effects on the multicore platform. Rapidemons support this by applying configurable degrees of contention on specific shared hardware resources by applying high traffic on them. This allows tests to be run that measure the impact of interference on multicore timing behaviour. In our demo, we use a Rapidemon that generates accesses on our platform's L2 cache to measure the impact of contention on this cache. Rapidtime and Rapitask instrument the multicore software so that timing metrics, values from performance monitoring counters on the hardware, and task level scheduling metrics can be collected during tests. Rapitest turns input tests, Rapidemons and instrumented code into a test harness that can be run to collect results. Tests specify the core on which the application is running, the behaviour of the test, including the metrics to be collected, and the configuration of Rapidemons needed to run the test. In our demo application, we will collect execution time metrics and 2 different values from performance monitoring counters: CPU cycles and L2 cache misses. These values will help us demonstrate any interference that is present and validate our comparisons. To test the impact of L2 cache contention on worst case execution time in our demo, we write a set of test scenarios, a control where our application is running on 1 core, and 3 tests where our Rapidemon is running on 1, 2 or 3 other cores. Our application is running on core 0 in each case. The next stage in the workflow is running the tests on target to collect results. Tests can be run on target from within the RVS user interface, or they can be run separately and results later imported into RVS. You can use a wide range of hardware to collect results from multicore tests. In our demo, we use the RTBX to collect results. Rapidtime lets you merge results you collect from different test runs. This helps if you want to collect results in parallel on multiple instances of your platform, supports testing on platforms with limited data collection capabilities, and lets you merge results from different tests so you can access all of your results from a single report. In our demo, we collect our results in 2 batches, which we merge to produce a final report. After you run multicore tests, RVS makes it easy to analyse your results. Rapidtime presents multicore timing results and values from performance monitoring counters observed during tests. It lets you check the distribution of collected metrics, including execution time across different tests, so you can verify whether your requirements are met. You can compare results from different tests to easily identify the impact of interference in multicore timing behaviour and performance metrics such as cache misses. Comparing results against a control is a convenient way to analyse results. Our results show that our demo application is sensitive to resource contention on the L2 cache. When compared to a control with no Rapidemons running, tests run with a Rapidemon targeting the L2 cache running on 1, 2 or 3 other cores increase the software's execution time by a maximum of 20%. The higher values for L2 cache refill demonstrate that more L2 cache misses occur when the Rapidemon is running. Comparing this against our timing requirement, we can see that, while the execution time increases as we apply more contention to the L2 cache, the worst case execution time is still lower than the higher bound specified in our requirement. Rapitask lets you see the task level scheduling behaviour of the application from a high level, making it easy to understand this behaviour and locate rare timing events. In this demo, we can see the tasks running on each core throughout test execution. The final stage of the workflow is exporting results so they can be submitted for certification. RVS lets you create custom multi-core testing reports that capture the evidence you need for certification. You can select the text and results that you want to include in the report by generating a template file and using an API to the RVS results. For the demo, we generate a custom report that links to our requirement, describes our test scenarios, and includes the results we collected during the tests.